Okay, in this video we're going to talk about some concepts related to IP version 4 addressing, in particular classful addressing and classless addressing. So classful addressing is the most basic way and the original way to specify networks. And the easiest way to explain what that is if you're looking at decimal dotted notation, the division points for class A, B, and C are going to be on the decimal points, which is the network portion to the left, host portion to the right. Another way to say that is on byte boundaries within the 32-bit address. This was the only way that we had available to do this, or that was officially supported, from 1980 to 1993 when VLSM came out. A lot of classful addressing is still used today. So what are the classes? We have Class A. Class A has a subnet mask of 255.0.0.0. So on that first byte boundary, the first byte is the network portion and the remaining 3 bytes is the host portion. And in a Class A address, if you break it out in binary, the first bit of the IP is always 0. So that means we have 1 to 128. So there are 127 Class A networks. Each of these Class A networks can have almost 17 million addresses. So they're really, really huge. Some of the examples are MIT. They were one of the first things on the internet, so they grabbed a Class A for themselves. IBM, which is a huge global company. Something called DECnet. There used to be a computer company called DEC, Digital Equipment Corporation, that used to be really huge. I think they've been out of business for quite some time now. So that's Class A. If we go to Class B, the subnet mask is at the second decimal point. So the subnet mask would be 255.255.0.0. The first bits of the IP, if they are 10, they are a Class B IP address. There are a little over 16,000 Class B networks, and each of these Class B networks can have 65,536 addresses. As far as examples, at UK, our main public IP range is a Class B, but we also have about 4 or 5 more Class B networks that we use for several things. So that's Class B. Class C. The division point is the third decimal point, so the subnet mask is 255.255.255.0. The first bits of a Class C network are 110, so anything that starts with 110 is Class C. There are a little over 2 million Class C networks, and each Class C network can have 256 addresses. So as far as examples, there are literally millions of Class C networks. For the longest time in the 90s, you said, hey, I'm a company, I need 10 IPs. They were like, here, have a Class C. Another company calls up, I need 24 IPs. Okay, here, have a Class C, 256 addresses. So as we'll talk about down the road, the original divvying out of Class C networks was very wasteful. Same thing is true with Class A networks. How many IP addresses do we think MIT have? Students will respond, a lot. And I'll say 16 million. And they'll say, probably not. And I was like, maybe a million. But who knows, maybe less than that. So they're wasting at least 15 million version 4 IP addresses. Continuing on, A lot of times when I got to this point in my lecture, my students would argue with me that there's only class A, B, and C. Class A, B, and C are typically the only ones from an end user or company perspective we talk about, but there is a class D and there is a class E. Subnet masks are not defined. In the case of class D, the first bits of the IP are going to be 110, and this is used for something called multicasting, which is one machine sends a packet out, but it goes to a collection of machines. A lot of times using something like ghost to image computers will do that. You'll be in a lab of 34 machines. The teacher station will broadcast out an image, and those all 34 machines simultaneously will see the same packets. So that's kind of what multicasting is, or an example. And then finally, I already told you there was class E, subnet mask not defined. The first bits of the IP is 1111. This is a reserved class of machines for testing and research. So normally you would not be using this. So that's classful addressing. Now if we talk about classless addressing, this was created to allow the IPv4 address space to be used or given out more efficiently, which would extend the time until we ran out of IPv4 addresses, which some people declared happened a couple of years ago. When we talk about IPv6, we'll talk about this in much more detail. This is sometimes referred to as CIDR, which is classless interdomain routing. And it uses a slash notation for the subnet mask, like /24. /24 means there are 24 bits in our network portion of the address. The remaining 32 are for a host. /24, as I think we'll see in a minute, is the slash notation for a Class C network. The division point can be, quote, anywhere within the IP address, but really /2 is the smallest we can have, and /30 is the smallest we can have to have useful networks and useful subnets. So Class A is a /8. Class B is /16. As I said a moment ago, Class C is /24. If we had an address where the first 3 bytes and 2 bits into the 4th byte were the network portion, the last 6 bits were host bits, that would be a /26. Here the division point is in the first octet or the first byte, so this is a /7. And finally, this is a /12. You will have some homework assignments coming up where I have you convert from slash notation to decimal dotted notation subnet mask and vice versa. So that finishes up the discussion of classful and classless addressing.